Homework 4, Problem 1. Description. Use the secant method to find the single solution to the following equations listed below. So to begin, the first thing you'll notice is that for this assignment, I switched over to Python. Reason for that is because Mathematica was giving me a hard time trying to program the secant method into the code, and so I decided to go ahead and switch over to Python. Okay, with that out of the way, let's begin. So first off, I defined three functions here that represent the three functions within the textbook. And then these are the functions that we want to calculate the root of using the secant method, which I defined below. This is the code that I am using for the secant method. So to begin, I am defining a method called secant method for the aforementioned root finding method. This function is going to be taking in 4 parameters with the 4 parameters listed here. To begin, we have x0 and x1, which are going to be taking in values for where the root lies. These are preferably going to be integers. Next, we're going to have a parameter for function, which is going to take in a function. And lastly, we're going to be taking in a parameter called steps, which is going to be how many total steps or iterations we want to run the secant method. To begin, go ahead and define a result variable here that is equal to 0. Next, go ahead and define a loop, and while the number of steps is still greater than 0, check and see if function of x0 equals function of x1. If this is true, then we have a divide by error with however many steps remaining, in which case we just want to break out of the loop. If this does not hold, then we can go ahead and do the secant method calculation. And so this is what these 2 lines of code here are doing, here on lines 49 and 50. It's running a calculation of the secant method, and then what we want to do is set result, the variable up here on line 38, equal to x2, the result we got from running the secant method. And then we want to decrement steps by 1, and then set x0 equal to x1, and then set x1 equal to x2. And then, if the number of steps is still greater than 0, repeat the process, and then, once all the process has been completed however many times the user has requested, or until we get divide by 0 error, go ahead and return the result. Once we get the result, we can go ahead and print out the result to the console. And that's what this main function here is doing. Just printing out the result for the root for each of the 3 functions that we defined previously using the secant method, each using 10 steps. And then when we run this, we get the following results. Function 1 has a root of 1.769. Function 2 gets a divide by 0 error with 2 steps remaining, meaning it was able to get the error with no precision lost after only 8 iterations, with a root value of approximately 1.672. And for function 3, we get a divide by 0 error with 3 steps remaining and a root value of approximately 1.1299.